is not defined at 0. So the requirement is we can find a critical number from f prime being undefined, but at x values where the function is defined. But at 0, the function is not defined. So, none. Useless. Even if I write x equals 0, it's not a critical number because the function is not defined at 0. Okay, what is the other option? Okay, let's say Oscar. What do you think? What is g prime being 0? What does that give us?
No, I have no idea.
Anyone?
Would -2 work?
Of course, the only one is -2. A fraction is 0 only when the top is 0. X plus 2 equals 0 means x equals -2. Awesome. What do I need to do next? After I found the critical numbers or critical number, what do I have to find next? Let's also find the limits here. From these two terms, which is the most powerful one? Better here. Maybe I should ask on this one. Which one counts at infinity?
The -2/3 one?
This one?
Yes.
At infinities, this is 0. Doesn't even exist. It's 1 over infinity. So small, very close to 0. So when I plug in negative infinity here, what do I get?
Negative infinity.
Thank you. When I plug infinity here, what do I get?
Infinity.
That's it. Good. Okay. So then now, what is the next step? So I determined the critical number. What was the next step? What did we do?
Study the sign.
Yep. Good. So here is the derivative. And we need to study its sign. Okay, so let's pick like -10, a number here. -10 plus 2. I don't need anything but the sign. Tell me the sign of the top when we plug in -10.
Negative.
Yes. And when we plug in -10 here, what is the sign?
It's also going to be negative.
Thank you. What is negative over negative then?
Positive.
Good. Done. I need to plug in -1 right here. And then a number like 1. -1 plus 2. Sign.
Positive.
Perfect. -1 cubed and blah, blah, blah. It's already the same thing. So this will be negative. Now I'm going to plug in 1. 1, 1. What is the sign of the top with 1?
Positive.
And the sign of the denominator?
Positive.
Very good. I need to determine this value here. I need to plug in -2 in the function. Ugly function, ugly number to plug in, but I have no choice. So this is the function. So I need, in parentheses, -2 caret 1/3, and then minus, in parentheses, -2 caret, parentheses, -2 divided by 3. Okay, just give me a number. -1.9, approximately. Okay, moment of truth. If these two don't go well together, and maybe I should determine this as well. Let's determine these. Okay, the limit from the left and the limit from the right of 0. Let's do that to complete the table. So we want to find the limit as x approaches 0 from the left of, which one is more convenient? X minus 1 over the cube root of x squared. That's the most convenient. And limit as x approaches 0 from the right from x minus 1 over the cube root of x squared. When we determine limits, what do we need to do first? If we want it or not, it doesn't matter, we have to.
Plug it in.
Yes, the numerator goes where, please?
Numerator goes negative.
-1 in both cases. Good. What about the denominator? Where does the denominator go?
Undefined.
It goes to 0. No, the denominator goes to 0. Okay. So now I know that the answer has to be this, but I don't know the sign. That's all I care about now. Can anyone plug in 0 from the left, like -0.1? -0.1, and tell me the sign of that 0. How can 0 have a sign? Yes, sort of, so to speak. Anyone? Ian, would you tell us? What do you think?
I'm not sure.
So when you plug in -0.1, what is the sign of this expression? I only need a sign with -0.1.
Would be negative.
But it's squared.
Oh, so it'd be positive.
Good. So this is negative because it's -1 at the top. What about the denominator? What about the second limit? I meant to say.
Positive.
But it's the same thing. It's positive 0.1. It's still a positive number. It's still negative over a positive. So then what is the answer? Still negative. Good. So we know that x equals 0 is what? From chapter 2?
-2.
Very good. A vertical asymptote. Thank you very much. Who said that?
Person.
Thank you. So we have -infinity, -infinity. Okay. Only now I'm ready to check my work. If these two rows don't go well together, do not go in sync, then I'll say oops and start from scratch. Okay, so what does the function do when the derivative is positive?
Increasing.
Is this correct?
Mm-hmm. Yes.
What does the function do when the derivative is decreasing? What does the function do when the derivative is negative?
Increasing.
Is this correct?
Yes.
Okay,
Yes.
good. So now what does the function do when the derivative is positive?
Increases.
From -infinity to 0, is it increasing?
Yes.
And from 0 to infinity?
Yes. Still
Yes. Perfect. Now, there is no discussion here. You can say, but wait a minute, you just told us a minute ago, 10 minutes ago, whatever, that negative, undefined positive is a relative min. No, it's not, because the function is undefined. Actually, x equals 0, as we discussed, is a vertical asymptote. So this is not a point of extrema. What about here? Positive, negative, and 0. What type of point is -2, comma, approximately this? I should be able to calculate it exactly. What type of point is this? -2.
A max.
Yes, it is a relative max because the derivative is 0 and it changes sign. Also, I meant here to say that if I have -0, negative, or negative undefined negative, or positive 0 positive, or positive undefined positive, that is nothing. So I'm going to write it now. Note. So this is the first derivative. If it's positive 0 positive, positive undefined positive, negative 0 negative, negative undefined negative, this is nothing.
So
Not
that's just because it's in the middle of a line, right?
no. It's because it's something like this. It's always increasing. The function is always increasing, or the function is always decreasing. The function has to decrease and increase for a minimum, increase and decrease for a maximum. If the function is always increasing, there is no max min. If it's always increasing, no max min. If it's always decreasing, no max min. If it's always decreasing, no max min. So this is not a point called of extrema. Plural for extremum. So not a point of extrema. It's not a max, it's not a min, in other words. Not max or min. It's not a point of extrema. Very good. Any questions? Can we move on? Let's move on then. You didn't say anything, so you can think about it. We can go back to other types of functions, of course. How to find max min, specifically absolute, also called global max min on a closed interval. How to find the max min, in other words, in this case, absolute or global on a closed interval, question mark. Okay. So let's talk about the following function. This function doesn't go on forever. This is a typical situation or a closed interval. So let's say the x value here, so this is p, a comma f of a, and this is q, b comma f of b. So this function is on a closed interval a comma b. It has a local or relative max. It has a relative min. It also has an absolute min. And it also has an absolute max. So the relative max has to show an open interval around that point. This cannot be considered a relative max. I cannot show an open point. The function does not exist on this side. So a relative max or min cannot be at the end points of the interval. So relative max or min never at the end or ends of an interval. Never. The endpoints of the interval can be only absolute or max or min. Endpoints can be absolute max or min. So we can have this situation in which this is a relative, but also absolute max. Why is it relative? Because I can show the open interval. Why is it absolute? Because there is no other point above it. What is this? This is nothing. It cannot be a relative because I cannot show the open interval. The function doesn't exist on this side. This one is only an absolute min. It cannot be relative because I cannot show the open interval. So let's take a look at something like f of x equals x over x squared minus x plus 1. I'm trying to have all types of functions in everything we do. So let's look at natural log and also a trig function. Trig functions take a long time, but it's okay.